Hello, in this lecture we'll answer two questions. In both questions we'll find out the area of a trapezoid. So what is a trapezoid? Actually, a trapezoid is a quadrilateral with one pair of parallel sides. So this is trapezoid ABCD. And this trapezoid ABCD, side AB is parallel to side DC. So the two parallel sides AB and DC are defined as the bases of the trapezoid. If we define the length of the base AB as B and the length of the base DC as A, then the area of this trapezoid will be equal to the sum of its two parallel bases, that is to say A plus B, times the height edge over 2. So the area of a trapezoid is a quadrilateral with one pair of parallel sides. And the area, the two parallel sides are defined as the bases of the trapezoid. And the area of a trapezoid is the sum of its two parallel bases times the height over 2. In this trapezoid ABCD, the two parallel bases are AB and DC. So if we define the length of AB as B and the length of DC as A, then the sum of its two parallel bases is A plus B times the height edge over 2. The height edge must create 90 degrees with the two parallel bases. You can see here that the height edge indeed creates 90 degrees with the base AB, and the height edge also creates 90 degrees with the base DC. So the area of trapezoid ABCD is equal to the sum of its two parallel bases, that is A plus B times the height edge over 2. Okay. In the first question, we find out the area of this trapezoid ABCD. It is given us the question that side AB of this trapezoid ABCD equals to 2 units in its length, and we also know that those two angles are right angles, and we know that side DC is equal to side CB, and the most important thing that we know is the perimeter of trapezoid ABCD is equal to 16 units. So actually, a perimeter is the sum of the lengths of all the sides of trapezoid ABCD. That is to say, it is AB plus DC, AB plus AD plus DC plus CB. Okay? We know that AB plus AD plus DC plus CB, in total it is equal to 16 units. That is the perimeter of this trapezoid ABCD. So I will write it down. So AB plus AD plus DC plus BC, in total the sum of the lengths of all the four sides of trapezoid ABCD is equal to 16 units according to what is given as the question. Repeat again. AB plus AD plus DC plus BC equals to 16. We define the length of this side AD as A. That is to say, AD equals to A units in its length according to our definition. We define the length of this side DC of this trapezoid ABCD as B. And because of the fact that according to what is given as the question, DC equals to BC, and DC equals to B according to our definition, therefore BC must be also equal to B. So, we know that the perimeter of this trapezoid ABCD is equal to 16. That is to say, AB plus AD plus DC plus BC equals to 16. AB is 2 according to what is given as the question, plus AD. AD is A according to our definition, so we substitute AD by A, plus BC. BC is B according to our definition, plus DC is B and BC is also B, so it is B plus B. So in total, the sum of the lengths of all the sides of this trapezoid ABCD equals to 16. That is to say 2 plus A plus B equals to 16. Here we subtract 2 from this equation and we get that A plus B is plus 2B equals to 16 minus 2 is 14. So in total we should find out that A plus B equals to 14. Here we subtract 2B from this equation and we get that A equals to 14 minus 2B. So we should find out that the length of this side AD is equal to A according to our definition is equal to 14 minus 2B. A equals to 14 minus 2B. In the next step, we will do a construction. That is to say, from the vertex B of this trapezoid ABCD, this vertex B, we will do perpendicular on DC again. From this vertex B, we will do perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DC. This point is point M. So by doing this construction, we created a quadrilateral ABMD. Inside this quadrilateral ABMD, we have 1, 2, 3 right angles. Those 2 angles are right angles according to what is given as the question, and this angle is a right angle according to our construction. So the sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4th missing angle, in total they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore this 4th missing angle must be equal to 90 degrees in its size. So inside quadrilateral ABMD we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be at least a rectangle and flat square. So we relate to quadrilateral ABMD is a rectangle because it has 4 right angles. This is quadrilateral ABMD, and it is a rectangle according to rule 5. But we also know that the opposite sides of a rectangle are equal to each other. So in this rectangle ABMD, side AB is equal to the opposite side BM. But AB is 8 is equals to 14 minus 2B, therefore the opposite side BM must be also equal to 14 minus 2B. Likewise, according to the same rule, in the same rectangle ABMD, side AB must be equal to the opposite side DM, but AB is 2, therefore the opposite side DM must be also equal to 2 units in its length. What is the length of this missing line segment MC? MC equals to DC minus DM. Again, MC equals to DC minus DM. So I write it down. The missing side MC is equal to DC minus DM. So MC equals to DC. DC is B minus DM. We just write down found out that DM equals to 2. So in total, MC equals to B minus 2 units in its length. MC equals to B minus 2 units in its length. So in the next step, I'll copy this right triangle BMC in a new page, and we will implement the Pythagoras theorem on this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is a relation for Pythagoras theorem. So actually, this is the right triangle BMC that I copied from the original drawing. Side BM equals to 14 minus 2B units in its length. According to what we have already found out, BM equals BC, the hypotenuse BC equals to B according to our definition. And finally, just right now found that MC equals to B minus 2 units in its length. So in this right triangle BMC, according to the Pythagoras theorem, BC squared, that is the square of the hypotenuse, is equal to BM squared plus MC squared. BC is B, therefore BC squared is B squared plus BM squared. BM it is equals to BM squared. BM is 14 minus 2B, therefore BM squared is 14 minus 2B squared plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total, we found out that, according to the Pythagoras theorem, we found out that B squared, in this triangle BMC, B squared equals to 14 minus 2B squared plus B minus 2 squared. So here we will open the brackets on this side of the equation, and we get that B squared equals to 14 minus 2B squared. 14 minus 2B squared equals to 14 squared, that is 296, plus 2 4 squared. 2 4 squared equals to 4B squared, minus 2 times 14, that is minus 28 times 2B, minus 28 times 2b is minus 56x plus b minus 2 squared. B minus 2 squared equals to b squared plus 2 squared, that is 4, minus 2 times b times 2, that is minus 4b. So if we found out that b squared equals to 296 plus 4b squared minus 56 plus b squared plus 4 minus 4b. So here we have 4b on both sides of this equation. So we have b squared on both sides of this equation, so b squared we get cancelled. After cancelled b squared, in this side of the equation we left with nothing, that is to say 0. While in the other side of the equation we have 296 plus here actually 14 square is not 296 but 196. So made a mistake. Again, 14 square is 196. So we have here 196 plus 4 is 200. And we have also minus 56b minus 4b is minus 60b. And we have plus 4b squared. So we actually found out that 0 equals to 200 minus 60b plus 4b squared. So here we divide this equation by 4 and get that 4b squared over 4 is b squared, and we have minus 60b over 4 is minus 15b, and 200 over 4 is 50. It is equals to 0 over 4 is 0. So in total, we found out that b squared minus 15b plus 50 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This is the general formula for a quadratic equation. A, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following general formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, the variable that we are looking for is b. Therefore, x equals to b. The coefficient a equals to 1. The coefficient b equals to minus 15. And the coefficient c equals to 50. The only thing that is left to do is to put this data for our specific quadratic equation inside this general formula for x, and we find out the value or the values of b, because x equals to b. The variable that we are looking for in our question is b. So we do it now. So x equals to b, so we substitute x by b and we get that b equals to minus b. B, the coefficient b is minus 15, therefore minus b is minus 15, that is plus 15, plus minus square root of b squared. B is minus 15, therefore b squared is minus 15 squared, that is 225, minus 4 times a times c. So it is minus 4 times a. A is 1, so minus 4 times 1 is minus 4, times c. C is 50, so minus 4 times 50 is minus 200. So inside the brackets we have only, inside the root we have 225 minus 20, divided by 2a. A is 1, so 2 times a is 2 times 1, that is 2. So if you found out that b equals to 15 plus minus, and inside the root we have 225 minus 200, that is 25, so inside the root we left only with 25 over 2. So if you found out that b equals to 15 plus minus, and the square root of 25 is 5 over 2. So here you have two solutions that are possible for b. We define the first solution for b is b1, and the second solution for b is b2. So the first solution for b is b1. It is equal to 15 plus 5 over 2. 15 plus 5 is 20, and 20 over 2 is 10. So the first solution for b, b1 equals to 10. And we also have the second solution for b that we define as b2. The second solution for b is b2 equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for b, b2 is equal to 5. So the first solution for b is b1 equals to 10, and the second solution for b is b2 equals to 5. We know that AD is one side of trapezoid ABCD, so AD is a length, and as a length it must be a positive number. So AD, that according to our definition is equal to A, and we found out that A equals to 14 minus 2B. So again, AD is a length, and therefore as a length it must be a positive number. And we know that the length of AD is 14 minus 2B. So 14 minus 2B must be a positive number. 14 minus 2B, that is the length of AD, must be a positive number. That is to say, it must be greater than 0. We will add 2B to this inequality, and we get that 14 is greater than 2B. Here we divide this inequality by 2, and we get that 14 over 2 is 7, greater than 2B over 2 is B. So B must be less than 7 units. B must be less than 7 units. But according to the first solution for B, B is equal to 10 units. B 1 equals to 10 units. 10 is greater than 7, but B must be less than 7. Therefore, this solution is an incorrect solution. We cancel the solution, and we left only the second solution for B that is possible for B, that is B2 that is equals to 5, or B equals to 5. So she found out that B equals to 5 units in its length. So here we know that the length of AD, that is A, is equals to 14 minus 2B. B is 5, therefore minus 2B is minus 2 times 5, that is minus 10. And 14 minus 2B is 14 minus 10, that is 4. So she found out that A equals to 4 units in its length, or AD equals to 4. Okay? It is given us the question that AB equals to 2, and DC equals to 2 plus B minus 2B. B is 5, therefore B minus 2 is 5 minus 2, that is 3. So in total, DC equals to 2 plus 3, that is 5. DC equals to 5 units in its length. DC equals to 5. AD equals to 4. And AB equals to 2. Our mission is to find out the area of this trapezoid ABCD. So actually, according to the formula that I presented to you in the beginning of the lecture, the area of trapezoid ABCD is equal to the sum of its two parallel bases. This trapezoid ABCD is very easy to see that AB is parallel to DC. So the two parallel bases are AB and DC, and the sum of those two parallel bases is AB, that is 2, plus DC, that is 5. So first of all, we write it in letters, and then we put the numbers inside the letters. So the area of trapezoid ABCD is equal to the sum of its two parallel bases, that is actually AB plus DC, times the height. The height is AD because of the fact that AD creates 90 degrees with the two bases. The height is AD over 2. We already found out, according to what is given as the question, AB is 2 plus DC. We already found out that DC equals to 5. Times AD. AD, the height AD is 4. Divided by 2. So in total, we found out that the area of trapezoid ABCD is equals to 2 plus 5 times 4 over 2. 2 plus 5 is 7. And remember, 4 over 2 is 2. So in total, this expression equals to 7 times 2, that is 14 square units. So if you found out that the area of trapezoid ABCD is equal to 14 square units. repeat again, we should find out that the area of this trapezoid ABCD is equal to 14 square roots. So we finish with the first question. In the next step, I present to you the second question and answer of the second question of this lecture. Our mission in the second question is to find out the area of another trapezoid, that is this trapezoid. They have the same names, but they are different trapezoids. This is also trapezoid ABCD, but it is another trapezoid. In this trapezoid ABCD, side AD equals to 2x units in its length, side BC equals to x units in its length. Those two angles are right angles. This is angle A and B, that is also a right angle. Line segment MB equals to 2 units in its length. This is line segment AM, that is equals to 3 units in its length. Again, our mission is to find out the area of this trapezoid ABCD. First of all, we define angle BMC. This angle is alpha. So in the right triangle BMC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this firmness angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. We have actually rule 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. This is side DC of trapezoid ABCD. So, as a side of a trapezoid, it is absolutely a straight line. So this is a straight line. If you focus on the upper side of this straight line, DC at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. So which angles we have at the upper side of DC at point M? We have this angle that is alpha, this is a right angle, plus this missing angle. In total, the sum of those three angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line DC at point M. Exactly according to rule 3. In the next step, we focus on this right angle AMD. This right angle AMD, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees. Therefore, this first angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. So, it is very easy to see from the drawing that those two right angles, that is to say the right angle ADM, this right angle ADM, and this right angle, this one right angle BCM, they are actually similar to each other according to angle similarity rule. Both triangles have angle alpha. Both triangles have the right angle, and both triangles have 90 degrees minus alpha. Therefore, those two right angles are similar to each other according to angle similarity rule. So I write it down. This is the right big triangle ADM. And it's similar. This is the sign of similar to this right small triangle BMC. According to angle similarity rule. So repeat again. The big right triangle ADM is similar to the small right triangle BMC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AD of the big right triangle ADC over side MC of the small right triangle BMC equals to side DM of the big right triangle ADM over side BC of the right small triangle BMC and also it is equals to side AM of the big right triangle ADM over side BM of the right small triangle BMC. So repeat again. From the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. That side AD of the big right triangle ADM over side MC of the small right triangle BMC is equal to side DM of the big right triangle ADM over side BC of the small right triangle BMC, and it is also equals to side AM of the big right triangle ADM over side BM of the small right triangle BMC. AD is 2x over MC. MC is the missing side, so we limit the CTs, and it is equals to DM. DM is also the missing side, so we limit the CTs over BC. BC equals to x units in its length according to what is given as the question. And it is also equals to AM. AM is 3 over BM. BM is 2 according to what is given as the question. So in total, we found out that two x over MC equals to DM over x equals to 3 halves. Those two expressions are equal to each other, so we will create equation 1 from those two expressions that are equal to each other. So according to equation 1, we get that 2x over MC equals to 3 halves. 2x over MC equals to 3 halves. Here we multiply this equation by MC, and you get that 2x equals to 3 halves times MC. Here we will multiply this equation by 2, and then we will divide it by 3 simultaneously, and we get that MC equals to 2x times 2 over 3. That is to say, MC equals to 2x times 2 is 4x over 3. So in total, we should find out that MC equals to 4x over 3 units in its length. So I write it down, we should find out that this line segment MC or side MC equals to 4x over 3 units in its length. We will continue to focus on the long equation. In this long equation, those two expressions are equal to each other, therefore we get equation 2 from those two expressions that are equal. So we'll create equation 2 from those two expressions that are equal to each other. So according to equation 2, dm over x equals to 3 halves. dm over 2 equals to 3 halves according to equation 2. Repeat again, according to equation 2, dm over 2 equals to 3 halves. Actually it is dm over x. Here we have dm over x equals to 3 halves. It is not 2 but x. This is dm over x equals to 3 halves. So here we multiply this equation by x, and we get that dm, according to equation 2, dm equals to 3 halves times x, so 3x over 2. So this is the line segment dm of side dm that equals to 3x over 2 units in its length. In the next step, I'll copy this right angle BCM in a new page, and we will implement the Pythagorean with this right small triangle BCM. Here by PT is a motion for Pythagoras theorem. The hypotenuse BM equals to 2 units in its length, according to what is given as the question. BC equals to x, also according to what is given as the question. And just like now found that side MC of x multiplied BMC is equal to 4x over 3 units in its length. So actually, this is the right small triangle BMC that according to the original drawing. According to the Pythagoras theorem, this small right triangle BMC, BM square equals to BC square plus CM square. So I write it down. So BM square, that is the square of the hypotenuse, is equal to BC square plus MC square. BM is 2, therefore BM square is 2 squared, that is 4. It is equals to BC square. BC is x, therefore BC square is x squared. Plus MC square. MC is 4x over 3. Therefore MC squared is 4x over 3 squared. That is actually 16x squared over 9. So 4 equals to x squared. We multiply x squared by 9 and then we divide it by 9 in order to overcome factor of this expression. So it is 9 times x squared over 9 plus 16x squared over 9 plus 16x squared over 9. 9x squared plus 16x squared equals to 25x squared over 9. So in total, we should find out that 4 equals to 25x squared over 9. Here we multiply this equation by 9 and we get that 36 equals to 25x squared. Here we divide this equation by 25 and we get that x squared equals to 36 over 25. So here we take out of this equation and finally we get that x equals to the square root of 36, that is 6, over square root of 25, that is 5. So in total, we should find out that x equals to 6/5. Again, x equals to 6/5. Our mission is to find out the area of this trapezoid ABCD. So what is the trapezoid ABCD? According to the formula that I presented to you in the beginning of the lecture, the area of trapezoid ABCD must be equal to the sum of its two parallel bases times the height over 2. The two parallel bases are AD and BC. Therefore, the sum of those two parallel bases is of course AD plus BC. Times the height over 2. The height is AD. Why AD is the height? The height is DC, of course. The height is DC. Why DC is the height? Because of the fact that the height DC creates 90 degrees with the base AD and also creates 90 degrees with the other base BC. Therefore, the height of trapezoid ABCD is DC. It is times the height that is DC over 2. Repeat again, in total we found out that the area of trapezoid ABCD equals to AD plus BC, that is the sum of its two parallel bases, times the height that is DC over 2. Repeat again, the area of trapezoid ABCD equals to AD plus BC times DC over 2. AD equals to 2x plus BC, BC equals to x times the height DC. DC in total equals to 3x over 2 plus 4x over 3. Divided by 2. So now we found out that the area of trapezoid ABCD equals to 2x plus x. This is the sum of its two parallel bases times the height. The height in total is actually DC side DC of trapezoid ABCD is equals to 3x over 2 plus 4x over 3 divided by 2. 2x plus x is 3x. Inside the brackets we have 3x over 2 plus 4x over 2. So here we take 6 as a common factor out of these two expressions. That is to say, we will multiply both the numerator and the denominator of this expression by 3. In this way we get the common factor 6, because 2 times 3 is 6. So 3x times 3 is 9x, and 2 times 3 is 6. Likewise, we multiply both the numerator and the denominator of this expression by 2. By multiplying it by 2, in the denominator we have 2 times 3, that is 6. In this way, we actually created the common factor 6 for those two expressions. So 4x times 2 is 8x, over 3 times 2 is 6. So in this way we created the common factor 6 for those two expressions. So in total, we found out that the area of trapezoid ABCD, that is the area that we are looking for in this question, is equal to 3x times 9x plus 8x is of course 17x. So here we have to divide all this expression by 2. So we divide all those expressions by 2. So in total, we found out that the area of trapezoid ABCD is equals to 16 times 17x. In the denominator, we have 2 times 6. So here we have 3 in the numerator and we have 6 in the denominator. So we divide both the numerator and the denominator by 3. 3x over 3 is x. Therefore, in total, in the denominator we have x times 17x. Likewise, in the denominator we have 2 times 6, so 6 over 3 is 2. So in total, in the denominator we left with 2 times 2. So in total, if you found out the denominator of the ABCD equals to 17 times x divided by 2 times 2, that is 4. So in total, if you found out the derivative of the ABCD equals to 17 over 4 times x. We have already found out that x equals to 6 fifths. X equals to 6 fifths. Found that x equals to 6 fifths. Therefore, we substitute x in this expression by x. And we get that this expression will be equal to 17 over 4 times x. And x is 6 fifths. And we have 2 times x. So we have 6 fifths again. So in total, we should find out that the derivative of the ABCD equals to 17 over 4 times 6 fifths times 6 fifths. 6 times 6 is 36, and 36 over 4 is 9. So we cancel those two numbers. Instead of those two numbers, we write down 9, because 36 over 4 is 9. And we have also here 17 over 5 times 5 is 25. So in total, if you found out that the derivative of the ABCD is equal to 17 times 9 is 153 divided by 25. In terms of numbers, 153 over 25 is 6.12 square units. And that is the answer to the second question. Repeat again, we should find out that the area of this trapezoid ABCD, that is the area that we are looking for in this question, it is equal to either 153 over 25 square units. In terms of numbers, the area of this trapezoid ABCD equals to 6.12 square units. We finish with the second question. In the next step, I summarize the lecture. We'll start with the first question, of course. Usually, in both questions, we found out the area of a trapezoid. So, what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. This is trapezoid ABCD. It is a quadrilateral, and because of the fact that quadrilateral ABCD is one pair of parallel sides, it has one pair of parallel sides, that is to say, side AB is parallel to the opposite side DC. This quadrilateral ABCD is defined as a trapezoid. Those two parallel sides are defined as the bases of this trapezoid. And if we define the length of side AB, that is the first base of trapezoid ABCD is B, and we define the length of side DC is A, that is the second base. Then the area of this trapezoid ABCD will be equal to the sum of its two parallel bases, that is actually A plus B, times the height h over 2. Again, the area of a trapezoid is the sum of its two parallel bases times the height over 2. The height h must create 90 degrees with the two parallel bases. You can see that indeed the height h creates 90 degrees with the base AB, and it also creates 90 degrees with the base DC. So a trapezoid is a quadrilateral with one pair of parallel sides, and the area of a trapezoid is equal to the sum of its two parallel bases times the height that is h over 2. The two parallel bases are defined as the two parallel sides are defined as the bases of the trapezoid. Therefore, we can say that the area of a trapezoid is the sum of its two parallel bases times the height over 2. Okay. So, in this first question, our mission is to find out the area of this trapezoid ABCD. It is given us the question that the perimeter of this trapezoid ABCD is 16. That is to say, what is a perimeter? A perimeter is the sum of the lengths of all the sides of this trapezoid ABCD. Again, the sum of the lengths of all the sides of any trapezoid is equal to the perimeter of a trapezoid. So it is given us the question actually that side AB plus side AD plus side DC plus side CB, in total it is equal to 16 units. In addition, we know that AB equals to 2 units in its length, and we also know that DC equals to CB. That is to say, the length of side BC is equal to the length of side DC. Again, I mentioned, and we also know that those two angles are both right angles. Again, our mission is to find out the area of this trapezoid ABCD. First of all, we know that the sum of the lengths of all the sides of this trapezoid ABCD is equal to 16. So I can write down that AB plus AD plus DC plus CB equals to 16. AB plus AD plus DC plus BC equals to 16. AB is 2. AB is 2 according to what is given us in the question. Plus AD. Here we define side AD as A, and we define side DC as B. And because of the fact that DC equals to CB, CB must be also equal to B. So AB is 2, AD is A according to our definition, DC is B according to our definition, and BC is also B according to our definition. And in total it is equal to 16 because we know that the perimeter of trapezoid ABCD is equal to 16 units. So in this equation we have 2 plus A plus B equals to 16. Here we subtract 2 from this equation. We found out actually that 16 times 16 minus 2 is 14. And here we have A plus B is 2B, so A plus 2B equals to 14. Here we subtract 2B from this equation and finally found out that A equals to 14 minus 2B. Okay. This is side AD, that equals to A according to our definition, and A equals to 14 minus 2B. In the next step, we did the construction, that is to say, from the vertex D of this trapezoid ABCD, this point, we drew perpendicular on DC. Again, from the vertex D, we drew perpendicular on DC. So if this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. When you find the touching point of the perpendicular from point B and DC, this point is point M. By doing this construction, we can do quadrilateral AB, MD. Inside this quadrilateral AB, MD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of these 4 pieces again, in total must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, these 4 pieces again must be equal to 90 degrees in its size. So inside quadrilateral ABMD we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be at least right angle if not a square. So we relate to this quadrilateral ABMD is right angle because it has 4 right angles. But we also know that the opposite sides of the right angle are equal to each other. So left angle ABMD, side AB must be equal to the opposite side DM. But AB is 2, therefore the opposite side DM must be also equal to 2H in its left. Likewise, according to the sum rule, in the sum of the ABMD, side AD must be equal to the opposite side BM. But AD is equal to A and A equals to 14 minus 2B. Therefore, the opposite side BM must be also equal to A, that is 14 minus 2B. Okay. What is the length of this missing side or line segment MC? From the moment it is very easy to see that MC equals to DC minus DM. Again, MC equals to DC minus DM. So MC equals to DC. DC is B according to our definition minus DM. Just like the found out that DM equals to 2. So in total, MC equals to B minus 2. MC equals to B minus 2. In the next step, I copy this right triangle BMC in a new page and we implemented the Pythagoras theorem on this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So this is the right triangle BMC, that I copied from the original drawing. In this right triangle BMC, BC squared, that is the square of the hypotenuse, is equal to BM squared plus MC squared. BC squared equals to BM squared plus MC squared. BC is B, therefore BC squared is B squared, and it is equal to BM squared. BM is 14 minus 2B, therefore BM squared is 14 minus 2B squared, plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total, we can find out that B squared equals to 14 minus 2B squared plus B minus 2B squared. Here we open the brackets on this side of this equation and finally found out that B squared equals to 14 minus 2B squared equals to 14 squared, that is 196, plus 2B squared. 2B squared is 4B squared, and minus 2 times 14, that is minus 28 times 2B. Minus 28 times 2B is minus 56B. And we have here also plus B minus 2 squared. B minus 2 squared equals to B squared, plus 2 squared, that is 4, minus 2 times B, times 2, that is minus 4B. So here we have B squared on both sides of this equation, so B squared will get cancelled. After I cancel B squared on the side of the equation, we left with nothing, that is to say 0, while on the other side of this equation we have 196 plus 4, that is 200. Also we have minus 56 minus 4, minus 56b minus 4b, that is minus 60b, plus 4b squared. So in total we should find out that zero equals to 200 minus 60b plus 4b squared. Here we divided this equation by 4 and finally found out that 4b squared over 4 is b squared, minus 60b over 4 is minus 15b, and 200 over 4 is 50. And it is equals to 0 over 4 is 0. So in total we found out that b squared minus 15b plus 50 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to this general formula that says that x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say b squared minus 15b minus 50 equals to 0, the variable that we are looking for is b. Therefore, x equals to b, the coefficient a equals to 1, the coefficient b equals to minus 15, and the coefficient c equals to 50. So the only thing that is left to do is to put this data for our specific quadratic equation inside this general formula for x, and we find out the value of the values of b because x equals to b. Now, specific quadratic equation, the variable that we are looking for is b, so x equals to b. So we actually did it, and we substitute x by b because x equals to b, so b equals to minus b. B is minus 15, therefore minus b is minus 15, that is plus 15, plus minus square root of b squared. B is minus 15, therefore b squared is minus 15 squared, that is 225, minus 4 times a, that is 1. Minus 4 times 1 is minus 4 times c. C is 50, so minus 4 times 50 is minus 200, divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So b equals to 15 plus minus. Inside the root we have 225 minus 200 is 25. So inside the root we left only with 25 divided by 2. So in total we found out that b equals to 15 plus minus the square root of 25 is 5. So in total we found out that b equals to 15 plus minus 5 over 2. So here we have two solutions that are possible for b. We define the first solution for b as b1, and we define the second solution for b as b2. So according to the first solution for b, this is actually b1. b1 equals to 15 plus 5 over 2. 15 plus 5 is 20 and 20 over 2 is 10. So the first solution will be, that is to say b1 is equal to 10. And the second solution for b is b2. The second solution for b, b2 is 15 minus 5 over 2. 15 minus 5 is 10 and 10 over 2 is 5. So the second solution for b, this is b2 is 5. So we have two solutions for b. The first solution for b is b1 equals to 10, and the second solution for b is b2 equals to 5. Okay, so we know that AD is a length. AD is a one side of trapezoid ABCD. That is to say, it is a length. AD is equal to A is equal to 14 minus 2b, and 14 minus 2b represent a length. Therefore, as a length, it must be a positive number. 14 minus 2b that represents a length, it must be a positive number. What is a positive number? That is to say, it must be greater than 0. So here we added 2b to this inequality, and found out that 14 is greater than 2b. Here we divided this inequality by 2, and finally found out that 14 over 2 is 7, so 7 is greater than b over 2 is b. So b is less than 7. So we found out that b must be less than 7 units. But according to the first solution for b is equal to 10, and 10 is greater than 7. Therefore, this solution is a correct solution because b must be less than 7. So we cancel this solution, and we left only with the second solution that is possible for b, that is b2 equals to 5 or b equals to 5. Okay, So if b equals to 5, then here we have 14 minus 2b. B is 5, so minus 2b minus 2 times 5, that is minus 10. And 14 minus 10 is 4. So if you found out that the length of side AD is 4 units, here we have the C that is equals to dm plus mc. dm equals to 2 and mc equals to b minus 2. b minus 2 is 5 minus 2, that is 3. So mc equals to 3, dm equals to 2. So in total, the c equals to 2 plus 3, that is 5. The length of this side DC is equal to 5 units, AB equals to 2 units, and the height AD equals to 4. So the only thing that is left to do is to put the values that we found out inside the formula for the area of this trapezoid ABCD. In this way, we find out the area of trapezoid ABCD. Okay, again, our mission is to find out the area of this trapezoid ABCD. So what is the area of a trapezoid? According to the equation that I presented to you, the formula that I presented to you in the beginning of the lecture, the area of a trapezoid equals to the sum of its two parallel bases times the height over 2. The two parallel bases in this trapezoid ABCD are AB plus DC. Therefore it is AB plus DC. That is the sum of these two parallel bases is AB plus DC times the height AD. AD is the height because of the fact that it creates 90 degrees with the two parallel bases. So it is times the height over 2. AB is 2, DC is 5, and AD is 4. Divided by 2. 2 plus 5 is 7, and 4 over 2 is 2. So in total, this expression equals to 7 times 2, that is 14. So in total, we shall find out that the area of this trapezoid ABCD, that is the area that we are looking for this question, is equal to 14 square units. We finish with the first question. In the next step, I presented to you the second question, and we solve the second question of this lecture. The second question, our mission is to find out the area of another trapezoid, but with the same name, trapezoid ABCD. So in the moment we have trapezoid ABCD, side AD of this trapezoid ABCD equals to 2x units in its length, side BC equals to x units in its length. Those two angles are right angles. And this is angle A and B, this is also a right angle. AM equals to 3 units in its length. BM equals to 2 units in its length. Again, our mission is to find out the area of this trapezoid ABCD. That is a different trapezoid. It is not the same trapezoid of the first question. So, first of all, we define this angle, that is angle BMC as alpha. So in the right triangle BMC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this first angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Okay. So BDC is one side of trapezoid ABCD, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line DC at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the angles on one side of the straight line is equal to 180 degrees. Okay, so if we implement rule 3 in our drawing, it means that in our drawing the sum of the angles on the upper side of the straight line DC at point M must be equal to 180 degrees. So which angles we have at the upper side of this at point M? We have this angle that is alpha, this angle that is 90 degrees, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its side. Why? Because 90 degrees minus alpha in its side. This missing angle must be equal to 90 degrees minus alpha in its side. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of DC at point M according to rule 3. So the missing angle must be equal to 90 degrees minus alpha. So in the right big triangle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees. Therefore, this one missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Okay, so it is very easy to see that this big right triangle ADC is similar to this small right triangle BMC according to angle similarity rule. That is to say, in both triangles we have angle alpha, in both triangles we have right angle, and in both triangles we have angle 90 degrees minus alpha. Therefore, those two right triangles are similar to each other according to angle similarity rule. So write it down. Repeat again. The right big triangle AMDA is similar. This is the sum of similar. So the right small triangle BMC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AD of the big right triangle ADM over side MC of the small right triangle BMC is equal to side DM of the big right triangle ADM over side BC of the small right triangle BMC, and it is also equal to side AM of the big right triangle ADM over side BM of the small right triangle BMC. Okay, again, we derive that AD over MC equals to DM over BC equals to AM over BM. AD is 2x over MC. MC is the missing side. MC is the missing side, so we limit as it is. And it is also equals to DM. DM is the missing side, so we limit as it is. Over BC. BC is x. And it is also equals to AM, that is 3, over BM, that is 2. So in total, we should find out that 2x over MC equals to dm over x equals to 3/2. So those two expressions are equal to each other, therefore we get the equation 1 from those two expressions that are equal to each other. So according to equation 1, 2x over MC equals to dm over x. Again, 2x over MC equals to... Actually, those two expressions are equal to each other, therefore we get the equation 1 from those two expressions that are equal to each other. That is to say, according to equation 1, 2x over MC equals to 3/2. Again, 2x over MC equals to 3/2. If we multiply this equation by MC, we find out that 2x equals to 3/2 times MC. If we multiply this equation by 2 and then we divided it by 3 simultaneously, we found out that MC equals to 2x times 2 over 3. 2x times 2 is 4x, so in total this expression equals to 4x over 3. So in total we actually found out that MC equals to 4x over 3. This is side MC or line segment MC that is equals to 4x over 3 units in its length. We continue to focus on this long equation in the green light. Those two expressions are also equal to each other, therefore we get the equation 2 from those two expressions that are equal to each other. According to the second equation, dm over x equals to 3/2. And again, according to the second equation, dm over x equals to 3/2. If we multiply this equation by x, we found out actually that dm equals to 3/2 times x. this is line 7 dm or side dm, that equals to 3x over 2, or 3 half times x. Okay. In the next step, I copied this right small triangle BMC in the new page and we implemented the Pythagoras theorem on this right small triangle BMC. This is the right small triangle BMC that I copied from the original domain. BM equals to 2, the hypotenuse BM, according to what is given as the equation. BC also equals BC equals to x, also according to what is given as the equation, and found out that MC equals to 4x over 3. So we created the Pythagoras theorem on this right triangle BMC. By PT is the progression for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle BMC, BM squared, that is the square of the hypotenuse, equals to BC squared plus CM squared. Again, BM squared equals to BC squared plus MC squared. BM is 2, therefore BM squared is 2 squared, that is 4, and it is equals to BC squared. BC is x, therefore BC squared is x squared plus MC squared. MC is 4x over 3, therefore MC squared is 4x over 3 squared. 4x over 3 squared is 16x squared over 9. So in total, we should find out that 4 equals to x squared plus 16x squared over 9. Here we multiply x squared by 9 and then we divide it by 9 in order to have a common factor in this expression. So it is 9x squared over 9. So 4 equals to 9x over 9 plus 16x squared over 9. Now 9 is a common factor of those two expressions. Okay. Here we multiply this equation by 9, but here we have 9x squared plus 16x squared is 25x squared over 9. So here we multiply this equation by 9 and finally found out that 9 times 4 is 36. So here we multiply this equation by 9 and finally found out that 9 times 4 is 36. So 36 equals to 25x squared. Here we divided this equation by 25 and finally found out that x squared was to 36 over 25. Here we took a root out of this equation and finally found out that x equals to the square root of 36, 36 over square root of 25, 35. So in total we should find out that x equals to 6 fifths. X equals to 6 fifths. Our mission is to find out the area of this trapezoid ABCD. So, in the beginning of the lecture, I presented to you a new formula for the area of any trapezoid. According to the new formula, the area of any trapezoid equals to the sum of its two parallel bases times the height over 2. The two parallel bases in this trapezoid ABCD are, of course, AD and BC. So it is AD plus BC, that is the sum of the two parallel bases, times the height, that is DC. Why DC is the height? Because of the fact that DC makes 90 degrees with the base AD, and DC also makes 90 degrees with the other base BC. So DC is the height. So in total, the area of this trapezoid ABCD equals to the sum of its two parallel bases, that is actually AD plus BC, times the height DC over 2. So again, trapezoid ABCD equals to the sum of its two parallel bases, that is AD plus BC, times the height DC over 2. AD is 2x, BC is x, and DC in total equals to 3x over 2 plus 4x over 3. And again, DC in total equals to 3x over 2 plus 4x over 3, all divided by 2. 2x plus x is 3x. Here it took 6 as a common factor of those two expressions. That is to say, we multiply this expression by 3 and then we divide it by 3. 3 times 3x is 9x, and 2 times 3 is 6. And we have here 4x over 3. So we multiply both the numerator and the denominator of this expression by 2. 4x times 2 is 8x, and 2 times 3 is 6. This way actually we added x a second factor from those two expressions, out of those two expressions. Here 6 is a common factor from those two expressions. So here we have 3x over 2 equals to 9x plus 8x over 6. 9x plus 8x is 17x times 3x divided by 6. And we have to divide all by 2 also. So we have we divided both the numerator and the denominator of this expression by 3. So 3x over 3 is x. So total we left only with x times 17x. And in the denominator we have 6 over 3 is 2. So in total in the denominator we left only with 2 times 2. 2 times 2 is 4. So in total in the denominator we have 4, and in the denominator we have 17 times x times x. So in total we should find out that the derivative of the ABCD equals to 17 times x over 4. We already found out that x equals to 6/5. So we just substitute x by 6/5. So it is 17 over 4 times x. X is 6/5. We have x twice, so we have twice 6/5. So in total we should find out that the derivative of the ABCD equals to 17 over 4 times 6/5 times 6/5. 6 times 6 is 36, and 36 over 4 is 9. So we cancel these three numbers, and instead of them, we substitute them by 9. Because 36 over 4 is 9. Okay? So in total we have 17 times 9 in the numerator over 5 times 5, that is 25. So in total we should find out that the derivative of the ABCD equals to either 17 times 9 is 153 over 25. So the area of this trapezoid ABCD equals to either 153 over 25 square units, or in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square units. Okay, thank you very much.